Okay, hey, I hope you're still doing well on that PSAT test. So we're going over the Lewis dot structures homework. And so we already got established for calcium, its symbol is Ca. It is in group 2. So how many valence electrons? Hello, class, come on.
2.
Okay, there you go, thank you. So there's the symbol, there's the Lewis structure for calcium. Potassium. What group is potassium in? Thank you. Group 1, how many valence electrons?
1.
Have you ever heard of Special K cereal?
Yeah.
Okay. You know why they call it Special K? Because it's fortified with potassium. Have you ever heard of another cereal called Product 19? Another company, when Special K came out, another company came out with another brand of cereal. And they wanted to get some of the market that people were getting this fortified cereal. So they made one called Product 19. What is potassium's atomic number?
19.
Ah, there you go. Isn't that cool? That's pretty neat. Chemistry trivia. Argon.
8.
What's its symbol? AR. Come on, don't get ahead of us. It is in which group?
18.
Group 18, and it does have more than 8 electrons. So we're going to put 1, 2, 3, 4, 5, 6, 7, 8. Argon has 8 electrons in its outer shell. It's got 4 paired electrons. It is extremely stable. Aluminum. What is its symbol?
AL.
Capital A, lowercase l. And what group is it in? I can't hear you. What group is it in? 13, or 3-teen as I like to call it, because 3-teen means it has 1, 2, 3 valence electrons, and there's the Lewis structure for aluminum. Bromine. What's its symbol?
BR.
And what group is bromine in? It's one of the halogens. It's in group 17. So 1, 2, 3, 4, 5, 6, 7. It's got the same structure that we saw in fluorine from the starters. It's pretty reactive, not quite as reactive as fluorine. Bromine is the outer electrons are further away from the nucleus, so the nucleus can't hold on to them as well. So it still wants to get electrons, but it can't grab them as strong as fluorine. That's why it has a slightly lower electronegativity. Moving over to hydrogen, the best element around, I think, actually. What is its symbol?
H.
What group is it in?
1.
Now, when I was a kid, when I looked at the periodic table, they used to have, now I can't remember, did they have it here? No, it was over here. They had hydrogen also over here. And I remember I was kind of too serious as a kid and kind of nerdy, I guess. I didn't realize it at the time. That word hadn't been invented. But they used to have hydrogen over here because it does kind of have some properties of the halogens. It has 1 electron in its valence orbital. And so they kind of put it both. And I remember being really mad because I'm like, come on, which one is it? Why is that? That doesn't make sense to me. Just like, on the globes. Okay, well, I'm getting sidetracked. Sorry. Okay, we don't care about that. Carbon. Its symbol is C. What group is it in? What group is it in? 14. So now this carbon has these 4 unpaired electrons. It's not that it's so reactive, but it can make chemical bonds really easy because it's kind of like, imagine a 4-armed octopus. Okay, that'd be like a quadrupus, okay? And it wants to reach out and hold hands with other creatures, other electrons, okay? And so that's what it does. Okay, drop my mouth over here. Okay. So. Oh, anyway, so that's why it's so reactive, and it is the element of life. And it's fairly light, so it's easy to move around in systems. Helium. What's its symbol? Capital H, lowercase e. And what group is it in? Group 18. So how many valence electrons does it have?
2.
Okay, now remember, it only has 2. Most of the elements in group 18 have a valence of 8, but helium is so small, it's all by itself. Now, how many of you did this? Okay, yes, you followed my rules. Now, helium is an exception here. When we do the Lewis structure for helium, it's only got 1. It only fills up the first orbital. So it's got its 2 electrons paired. That'll make more sense as we get into electron configuration. So fix it if you need to. If you had the 2 down here, that's right, but we're going to go like this. Helium's 2 electrons are paired up, and they're happy. Now, Mr. Endler students, are you getting this written down? Because some of you look like you're in the Bahamas waiting for the soda person to come by. Okay. All right. Oxygen. What group is oxygen in? Group 16, so it has 6 valence electrons. This was from our starter, so this is kind of similar. So we'll do that. So that looks something like that. Now, I also want to let you know, let's draw oxygen again over here. A lot of times for convenience, when we're putting together molecule diagrams, we will put these 2 paired electrons like this, and then the unpaired electrons over there. Because when we start to hook up things like water, hydrogen to it, we just kind of rearrange things slightly to make it more convenient. And then phosphorus, I'm recording right now, so I don't want to stop. Phosphorus is P. What group is phosphorus in? 15. Which one? 15. Group 15. How many valence electrons does phosphorus have? 5. Okay, you know what? You sound like you're getting irritated. Good, I like that. That means you're getting the concept. And, oh, did I do hydrogen already?
Yes.
Did I just like skip that one? I don't know what I did. I don't know what I was thinking. Now, let's come on over here, number 11. We're going to do the Lewis structure for water. So I recommend when we do that, we're going to take I would recommend to fill it in kind of like this. Now, if you've already done it, you can do it again. So I'm going to put the 2 paired electrons right there. I'm going to put the unpaired electrons there. And then for hydrogen's 1 electron that they're each going to bring to the game, I'm going to put those in as an X. So hydrogen's got its there, this hydrogen there. So what happens is, when these pair up like that, oxygen thinks it has its outer orbitals full. That hydrogen thinks its outer orbital is full. And that hydrogen thinks its outer orbital is full. This is a covalent bond. They're sharing electrons. Everybody's really happy. Now, CO2, you got to set it up this way, and this one's not going to be real fun. Well, I guess we could start off. Okay, we go like this. Okay, and if you didn't do it the way I'm setting it up, I'd recommend redraw it. Now, we're going to get these set up like this. We'll put the 2 paired over here, the other 2 paired right there. We're going to put 1 unpaired electron there and 1 unpaired electron like that. And let's repeat the pattern over here. So what happens here is, so oxygen's got these 2 electrons that it needs to team up with somebody. This oxygen has these 2 electrons that it needs to team up with somebody. Carbon has these 4 electrons. So what it does, it takes a little more energy to make this bond, but let's draw a connection. This will connect to that one. This electron will team up with that one. This electron will team up with that one on oxygen, and this one will team up there. So now I'm going to redraw this. Now I'd like you to redraw it to clean it. What I say, clean it up a little bit. We're going to put carbon. We're going to put these 2 that it's sharing with the oxygen. Put the 2 dots there, representing the electrons. So after we clean it up, this is what the Lewis structure for a CO2 molecule will look like. And a lot of times, chemists will just draw lines connecting the paired electrons, and they draw molecular formulas. And that becomes a shortcut. In fact, a lot of times, they won't even bother to put the 2 paired electrons out there, and that's going to be the beginnings of drawing structural formulas. Now, down here for nitrogen, how many valence electrons does nitrogen have? Everybody look on there. I'm answering your question. How many valence electrons does nitrogen have? I didn't hear. What did they say? What'd you say? What group is it in? Mr. Endler student, what group is nitrogen in? 15. So 5 valence electrons. 1, 2, 3, 4, 5. Okay, good. So we got that one done. Oh, it kind of jammed in there. It's kind of. Let me redo it over here. Ends up like this. Nitrogen has 1 pair of electrons that are shared. It has 3 electrons that it wants to go out. And you ever heard of TNT? And I'm not talking Turner Network television here, okay? I'm talking about trinitrotoluene, the explosive. Okay, there's a lot of energy when nitrogen bonds those. So over here, let's draw this. We got nitrogens set up like that. And then for the hydrogens, I'm going to draw theirs as an X again. So what happens with ammonia, which this is what this turned out to be. Oh, I already wrote it there. Okay, focus there. So ammonia's, I know, this is how you feel, right? You're all blurry-eyed. Oh, are you kidding me? Really? Focus. We're almost there. Almost done. Is this the last one? Okay. So, stop it there. So we've got our nitrogen here. It thinks it's got 8 electrons, and each of those hydrogens thinks that they have 2 each of those hydrogens think they're helium, and and this one thinks it's neon. Lastly, fluorine ion. Okay, this is a tricky one we're going to throw at you. Let's first start. What's the regular electron dot diagram for fluorine? How many dots do we need to put? 7. It's in group 17. So 1, 2, 3, 4, 5, 6, 7. Now, the negative charge, has it gained 1 electron or lost 1 electron? It's going to gain 1 electron. I'll draw that as an X. And there we go. Then we have to put a negative sign. I'm going to just put a bracket to remind us that it's ionized, and that's the new charge. So there we go. Turning this off.